A is asking how many moles of C5H12 are needed to produce 3.90 moles of water. So first, one of the clue that was given is the balance equation. Let me write that balance equation here. So the balance equation is that C5H12 plus oxygen to produce 5 CO2 and 6 water. So if we do that, so 10, 16, that would be 8 oxygen here. So again, this is one of the stoichiometry problem. We just need to convert the moles of one into the other. So for A, we can see that we started with, let's start with 3.090 mole of H2O. That's what we are given. And we want to convert that to C5H12. So mole of C5H12 on top and mole of H2O on the bottom.
So that way we can cancel it out?
Right. And then because this one is mole to mole, so we can look at the balance equation. For every 1 moles of C5H12, that would be 6 moles of H2O. So that's going to be 1 to 6 over there. And then we just carry out the math. So mole of H2O cancel out with moles of H2O. So 3.90 times 1 divided by 6, that gives us 0.85 mole of C5H12 needed.
You got 0.85 or 0.65?
Oh, 65, sorry. 65.
I got 65.
Okay.
Okay.
And then for B, it's asking how many grams of H2O are produced from 33.8 grams of oxygen. So similarly, but then first we have to convert that to mole. So 32.8 grams of oxygen. So first thing we have to convert that to mole of oxygen for every gram of oxygen. So 1 for every 32.00, because each oxygen is 16.00 gram per mole, but this one is a diatomic molecule atom. So oxygen O2 has to be 32.00 gram per mole. So gram is out. So now we have moles of oxygen. So we just look at the balance equation again. For every 8 moles of oxygen, that would produce 6 moles of water. Do you see it? 8 and 6.
8. Wait, hold on.
So, from a balance equation, 8 mole of oxygen over here correspond to 6 moles of H2O.
Okay. So 6. 8.
Just stop responding to. So we have here. So 6 moles of H2O. And then they're asking for gram. So we just have to multiply. We have to convert that to gram. So gram of H2O for every mole of H2O. And from the and we just calculate the molar mass of that. Oh, it comes back here, so I can delete it. Just give me 1 second to delete something. This hideous writing. Okay, so give it a second. So we have to convert that to gram of H2O.
Grams. Okay.
So gram of H2O on top, moles of H2O on the bottom. And we have 18.02 gram of H2O for every 1 mole. And then we just carry out the calculation. We can see that moles of H2O is canceled, moles of oxygen is canceled, giving us only gram of H2O.
So then we multiply across.
So 33.8 divided by 32 times 6 divided by 8 times 12.02. That gives us 14.3 gram of H2O. You see it?
Two. Yes.
Okay.
14.
Uh,
14 point.
so yeah. So finally, it's asking how many grams of H2O are produced if we mix a certain amount of C5H12 and an amount of O2. So for this problem, we are given amount of both reactants. So every time when we are given the amount of reactants, we should go and check for limiting reactants. Do you understand what is a limiting reactant?
No, I don't. What's limiting?
Limiting reactant is a reactant that is used up first. So when you mix
Oh.
two things together, one
Uh-huh.
of them is going to be used up first.
Okay. Okay.
And once the limiting reactants are used up, the
Mm-hmm.
reaction stops because there's no more reactants. There's no more necessary reactants to move forward. So the amount of limiting reactant will decide the amount of products produced.
Okay.
There's different ways to figure out which one is the limiting and which one is the product. I mean, is the excess.
Mm-hmm.
One way to do that is that we're just gonna convert the amount from each reactant and compare the value. So I'm gonna start with C5H12 with 44.3 gram. Not something is wrong with the Wi-Fi. It's take too long to sync two devices.
Wait, so for the one that we just did, the 14 point, the on the top of the H2O, you put 14.39. Isn't it supposed to be 14.27?
14 point. Yeah, but I rounded up.
Oh, you rounded it up to 29?
Well, 27 because the 7 make it a 3.
Oh, okay. Okay. The Wi-Fi, I don't know why it's so slow.
Yeah, I wrote something, but it doesn't sync, so just give it a minute.
Oh my gosh. Oh. So when you're saying 14.39, is that 14.39 grams as the unit?
14.3.
14.3 grams, right?
Yeah, where did you get the 39 or 29?
Where did I get 29?
Yeah, you just said 29, right? Like
Oh, I said
14.39.
14.39 because I thought your G
That's
was a 9.
gram.
Oh, okay. So it's not a 9. That's why I was confusing myself. Grams.
Okay, so for C, I'm gonna start with 44.3 gram of C5H12, which is the first reactant. I'm gonna convert that to gram of H2.
H2O.
So first I have to convert that to mole. So moles on top, moles of C5H12, gram of C5H12 on the bottom. And this is C5H12, so C5H12. So 5 carbon, which is 12.01 gram per mole, plus 12 of oxygen, hydrogen, which is 1.01 gram per mole, and 5 times 12.01 plus 12 times 1.01, that is 72.17 gram per mole. So we have here is 1 mole for every 72.17 gram. So we can see that gram is canceled.
Yeah.
So now we convert from moles of C5H12 to moles of water. So by looking at a balanced equation over here, we can see that 6 water for every 1 C5H12. So we have 6 over 1.
Oh.
And then finally, we convert that to mass. So 18.02 gram of H2O for every 1 mole of H2O. So we can see that moles of C5H12 is canceled, moles of hydrogen is canceled, leaving us with gram of H2O. So let's see, 44.3 divided by 72.17 times 6 times 18.02. That gives us 66.37 gram of H2O. So this part of it. Now we have to do the same process with the other amount of the other reactant, which is 108 gram of oxygen. So same process. So first we have to convert that to mole of oxygen for gram of oxygen, and 1 mole is 32.00 gram from the periodic table. And then we convert that to mole of H2O per mole of oxygen from the balanced equation. So 6 to 8, so 6 water for every 8 O2. And then finally, we do 18.02 gram of water for every 1 mole of water. So if we look at a unit cancellation, gram of O2 out, moles of O2 out, moles of H2O out, giving us gram of H2O. So let's see, 108 times 32, divided by 32 times 6 divided by 8 times 12.02. So it's 45.61 gram of hydrogen. So you can see that of the two numbers that was given, this one, the second one is the lower values, right?
Yeah.
So this one is the answer.
Because it has the lower value?
Right. And oxygen is called the limiting reactant.
Oxygen. Oh.
And C5H12 will be the excess.
Oh, that makes sense. So it would be 40 point. Let's try 45 point.
Yeah. Okay.
Yeah.
All right. Let me stop recording.
Take a picture or something.